Hello everyone, welcome to PW. So today we are going to discuss about the questions based on the electrical machine. It's a new series, it's a revision through question series. In this I am going to discuss some very important concepts through the question, okay? So it will going to recall you the entire electrical machine with the help of question. Please let me know by writing in the comment section that everything is okay, you are able to understand and you are able to hear me. Good evening beta. Great. If you have any doubt related to the how I am going to start, you can ask me in the comment section. I have planned here, there will be some question of the entire electrical machine based on the transformer, induction, synchronous and all. And we are going to discuss the problem. And while discussing the problem, I am going to tell you about the concept related to the question also. Okay. So hoping you are able to understand. Please let me know. May I start? Great. Yes, sir. Just you can make a thumb. Great, sir. Now please see. So first question. I'm going to start with a different question. Okay. This is pure in English language only. If you have any issue with any terminology, you can ask me. Please see. Open circuit. First question. You need to take out your calculator. Please take a rough sheet in order to solve these questions. And try to be going with the live only, because I am going to tell you about the important concept based on these questions. Now please see. The open circuit and short circuit test result of a 20 kVA 400 by 200 volt single phase transformer are as follows. Open circuit test result 200 volt, 3 ampere, 500 watt. Great, sir. Short circuit test result 100 volt, 80% of the rated current and 640 watt. The value of maximum efficiency of the transformer will be. So I have tried to combine two different concepts in one question, that is efficiency and testing. Good evening, Shubham. So whenever open circuit and short circuit test results are given to you, then first you need to understand whether OC and SC test are conducted on rated voltage and rated current respectively or not. If OC test is conducted at rated voltage and rated frequency, it gives a rated core loss. And if SC test is conducted at rated current, then it gives rated copper loss, also called as a full load copper loss. So whenever this type of question comes, first of all you have to identify the rated losses. So please observe here. Yes, sir. 200 volt is the rated voltage of the transformer, and at 200 volt the loss is 500 watt. It means this is a rated iron loss. Okay. Now next is reduced voltage. Yes, we know that, sir. Short circuit test is always conducted at reduced voltage only, so it is okay. 80% of the rated current. When I am saying 80% of the rated current, it means this is not a rated copper loss. Means it is not a full load copper loss. But we can calculate, sir. Is it okay? We can calculate from here a full load copper loss. Then we need to find the value of maximum efficiency of the transformer will be. So we know about the condition at which efficiency of the transformer is maximum, and then we can use the formula. So please try. Okay. Let me help you out. Sir, open circuit test is conducted at rated voltage and rated frequency. Open circuit test is conducted at rated voltage and rated frequency. OC test is at rated voltage and rated frequency. Rated voltage and frequency. Yes, sir. So it means we have rated iron loss. What is rated? Rated iron loss is 500 watts. Rated means whatever the values are mentioned onto the nameplate of the transformer. Okay, great, sir. Further, you can say, sir, once we have this OC, from OC test we have this, and from SC test is conducted at 80% of rated current. Yes, sir. So, very important information is coming from here, that we know that X square PCUFL is your operating copper loss, where X is the loading factor. Yes, sir. X is the loading factor. So, sir, 80% of full load means 0.8 square PCUFL is equals to, this is given in the question, 80% of the rated current. What is the copper loss? 640 watt. So what is the operating copper loss? 640 watt is the operating copper loss when the test is conducted at 80% of the rated voltage, and this will help you to calculate full load copper loss. Great, sir. So this will be 0.64 only, and you can clearly write it out here as 1 kilowatt or 1000 watts. Great, sir. Hoping you are able to understand up to this part. Great, sir. Further, once we have full load copper loss, now we can move to the efficiency. What is maximum efficiency? Sir, we all know that condition for maximum efficiency is, sir, iron loss must be equals to operating copper loss. Yes, sir. Operating copper loss. Or you can say, sir, copper loss must be, variable loss must be equals to constant loss. Better to write variable loss must be equals to constant loss. Yes, sir. Power factor, it is not going to be affect here because it is given that we need to find the maximum efficiency only. So we know that in terms of power factor, efficiency will be maximum only at unity power factor. Is it okay? Yes, sir. So efficiency will be maximum at unity power factor, and also when variable loss is equals to constant loss. What is variable loss? Sir, copper loss is a variable loss, so you can write it here as X square times of PCUFL. Now what is this X? This X is the loading at which efficiency is maximum. This X is the given a loading in the testing. Now this X is the loading at which efficiency is maximum. Okay, and that will be equals to Pi. Yes, sir. So what is the loading at which efficiency is maximum? Pi by PCUFL. If you have any doubt, please feel free to ask in the comment section. Great. Now from here you can write it as 500 by 1000, that is 1 by root 2. So this indicates 0.707. So 0.707 means at that particular loading, efficiency of this particular transformer is going to be maximum. Okay. Yes, sir. Further, you can say, sir, what is maximum efficiency? So maximum efficiency is kVA at which efficiency is maximum into cos of phi 2, in case if the power factor is mentioned, upon kVA at which efficiency is maximum into cos of phi 2 plus of 2pi. Why I am writing 2pi? Because PCUFL is equals to X square PCUFL is equals to Pi. Okay. Yes, sir. This is the maximum efficiency condition. It means variable copper loss must be equals to constant loss for maximum efficiency. I am just substituting the values here. So efficiency is maximum in terms of power factor at unity. Yes, sir. So I am going to put it as unity. And what is kVA at which efficiency is maximum? So please observe here, kVA at which efficiency is maximum is rated kVA under root of Pi by PCUFL, where remember this to be the PCUFL is a full load copper loss. So what is the maximum efficiency? Sir, maximum efficiency is nothing but rated kVA, it is given 20 kVA transformer, okay, into 1 by root 2. Cos phi is unity, sir, because cos phi is not mentioned while asking for a maximum efficiency. So we know that maximum efficiency occurs at unity power factor, then 2 times of, what is iron loss in terms of kilowatt? You can say, sir, iron loss in terms of kilowatt is 0.5. So I'm just substituting iron loss in terms of kilowatt, because 20 kilo kVA into cos phi is kilowatt. So now everything is in kilowatt only. Okay, you can just multiply by 100 in order to find the percentage maximum efficiency. Hoping all of the important things related to this questions are recalled, like condition at which efficiency is maximum, kVA at which efficiency is maximum, how to find the copper, how to find the full load copper loss and all. Please let me know by writing in the comment section. If you have any issue, anything if you want to ask, please feel free. Please feel free. So what is the answer? It is around 93.39%. You can approximate it as 93.4%. Whenever options are given, then okay, it is very easy. In case if you have to substitute the values, if you have to fill the values NAT type, then for NAT type, always properly read about the units in which they are asking. They may ask like if they are asking the kVA at which efficiency is maximum, they may ask VA at which efficiency is maximum. So that NAT type units in which answer is asked, that is very important. And in case if it is mentioned like round off up to 2 decimal places, then that rounding off is also important. Always remember, if you are substituting any values, you can put it near to the 2 digits of the decimal places. Is it okay? Great, sir. Hoping up to this part everything is clear. Now you can easily solve the questions based on the transformer efficiency, the current at which efficiency is maximum. In case if the power factor is not mentioned, how to take the power factor for a maximum efficiency condition. Is it okay? Great, sir. Now come to the next question. Please observe next question. Please observe. Two single phase transformer, very important, because efficiency, parallel operation, some topics are very important for this particular exam, GATE 2023, very important. Please see. Two single phase transformer rated as 1500 kVA, rated as 1500 kVA and 750 kVA respectively are to be operated in parallel. They have a equal ratings and their per unit impedances are 0.25 plus J 0.075 and 0.125 plus J 0.0375 respectively on their own basis. Very important. On their own basis. If a unity power factor load of 2000 kVA is connected across the parallel combination, then the load shared by 1500 kVA transformer will be. Okay, try to solve it. Try to solve it. Very easy. When two transformers are operating in parallel, and in case if the voltage ratings are not mentioned, it means they have same voltage ratings. Okay, always remember this. Okay, next thing is, it is given that one transformer is of 1500 kVA and one transformer is of 750 kVA. So many students thought that this combination can share a load of 1500 plus 750 kVA, but that is not true. That is not true. Why, sir? Okay, so soon I am going to tell you why. Per unit impedances on their own base values are also mentioned to you at unity power factor load, and 2000 kVA is the total load connected across the parallel combination. It is given that if a unity power factor load of 2000 kVA is connected across the parallel combination, then the load shared by the 1500 kVA transformer will be. We need to find the load shared by 1500 kVA transformer. I'm also asking what is the maximum possible parallel combination load. In case if we thought whether it can goes up to the maximum possible parallel combination or not. Like if we are going to add these two. So please observe here, we have two different transformer. Yes, sir. So we have two different transformer. I'm representing here a parallel combination of the transformer. Okay. The induced EMF of the transformer can be represented by a voltage source, and the winding resistances and reactances can be represented by a internal impedance of that voltage source. Yes, sir. So we have two transformer. Let transformer EA and transformer B as EB. Okay. Yes, sir. This will have RA plus JXA and this will have RB plus JXB. Yes, sir. And now these two transformers are connected in parallel to feed a load of, it is given that 2000 kVA. Okay. At unity power factor. So we know about the load also. Great, sir. This to be the common terminal voltage this. Let us suppose the current shared by the transformer A is IA and current shared by the transformer B is IB. So we can easily identify, sir, in case if EA is equals to EB, they are always in same phase. Okay, they are always in same phase. If EA is equals to EB, we can say equal voltage ratio. Whenever in the question equal voltage ratio is not mentioned, in the parallel operation always take equal voltage ratio. Is it okay? Great, sir. Now their impedances are given, like ZA and ZB are given. Yes, sir. But this ZA and ZB are given on their own base values. Yes, sir. Let me write it. ZA is 0.025 plus J 0.075 per unit, and ZB is also given to you as 0.0125 plus J 0.0375. Okay, but they are in per unit on their own base values. Yes, sir. Now please observe. If both are on the common base, then you can say, sir, EA and EB are equal. So you can say, sir, a single voltage source with the two parallel. And now we can easily identify the current delivered by each of the transformer by a current division rule. So current delivered by transformer A will become IL into, let this to be the impedance ZA and this to be the impedance ZB. So you can say, sir, IL into ZB upon ZA plus ZB. But they should be on common base, because we know that base impedance is, what is base impedance? Sir, base impedance is, since base impedance is KV base square upon MVA base. KV base square upon MVA base. So if I am considering this to be in per units, then their base must be same. A transformer and B transformer base must be same. Then you can put the ratio ZA upon ZB upon ZA plus ZB in per unit also. Is it okay? Yes, sir. So this shows, since Z base is this, so in above ZA and ZB are either in actual ohms or in per unit on common base. Most of the students do the mistake here. They forget to change a common base. Is it okay? Yes, sir. So here, if you are going to put the values in per unit, ZA and ZB, for finding the current delivered by transformer A or current delivered by transformer B, then it should be in per unit in a common base only. Okay? Great, sir. Now please observe here. KVA delivered by transformer A. When I am saying delivered, it means out. So what is KVA out? Voltage into current. Yes, sir. So you can write it here as V into IA conjugate. Okay. Yes, sir. So if I am writing here as SA is the KVA delivered by transformer A is V into IA conjugate. Further you can write, sir, SA conjugate will become V conjugate into IA. Okay, I am interested to find the KVA delivered by transformer A only, where A is a 1500 KVA transformer, I am assuming in this question. Okay, so they have asked about the 1500 KVA transformer. Now please observe here. If you remember the formula, you can directly proceed from the formula. Sir, SA conjugate can be represented as, okay, V into IA can be represented as IL into ZB upon ZA plus ZB. So V into IL is going to be SL. Okay, yes sir. So you can write SL conjugate into ZB upon ZA plus ZB. If you have any issue, please feel free to ask. Please feel free to ask. Okay, sir. This is given. Load KVA is given to in the question. Load KVA is given in the question as 2000 KVA. Okay. Yes, sir. So this is given as 2000 KVA into what is ZB? ZB is given to you. ZB. Whether ZB is given or not, sir, ZB is in per unit on a base value of transformer B, that is 750, and ZA is the per unit value on the base of 1500. So we need to find the common base in order to use this formula. Yes, sir. So first I am interested to find the common base, and just I am writing here let. You can take any transformer KVA rating as a base KVA. Okay, they have both the transformer will have same voltage rating, so we need not to care about the voltage rating. I'm just taking KVA. Okay, so let the base KVA be 1500 KVA. So ZA will remain ZA. We need not to calculate ZA again. Yes, sir. We need not to calculate ZA again. Yes, sir. Now what about ZB? We have to take ZB on a new base. So ZB on base new base is ZB on old base into MVA base old by MVA base new. Sorry, MVA base new by MVA base old. Okay, MVA base new by MVA base old. Yes, sir. Further, you can just substitute the value. So this will be 0.0125 plus of J 0.0375 into what is new base? 1500. What is old base? 750. So you can easily calculate a Z base new. Great, sir. So Z base new will become 1500 by 750 into 0.0125 plus of 0.0375 I. Okay. Yes, sir. So this will be 0.025 plus of J 0.075. Okay, great. Now, if you observe, both ZA and ZB are going to be equal. When the per unit impedances of the two transformers are equal on their own base value, then only they can share a maximum. This is per unit values on common base. They are not going to share maximum. Is it okay? Yes, sir. So this is very important. That is why the data I have chosen in this format. Now please observe here. You can easily write, sir, this will become ZB is a 0.025 plus of J is 0.075 by 0.025 plus of J 0.075. Okay, into 2 you can write, because both ZA and ZB are same. Because both ZA and ZB are same. on common base. So this will be 1000. Yes, sir. One thousand kVA. So it means 1500 kVA transformer is going to share a load of this one. Yes, sir. At an angle 0 only. So you can observe from here which one is correct. Which one is correct? If you have any doubt related to anything, please feel free to ask. If you have any doubt related to anything, please feel free to ask. So, this parallel combination is going to, if the unity power factor load of 2000 is connected across the parallel combination, then the load shared by 1500 kVA transformer will be 1000 kVA, which is none of the above. Is it okay? Great, sir. So hoping you are able to understand this question properly. Okay, I'm also asking how much maximum load this parallel combination can feed. So it's very clear, sir. It's very clear, sir. When we talk about maximum load, then they are not going to share a maximum load as 1500 plus 750. Why? They have a different per unit impedances on their own base values. Is it okay? If you have any doubt, please feel free to ask. Great, sir. They have same per unit impedances on common base, but they don't have same per unit impedance on their own base values. When the per unit impedance on their own base values are same, then only the maximum loading is equals to rated kVAs of the transformers. By addition, maximum load can be obtained by adding the rated kVAs of the transformer. Otherwise, we need to follow a different rule. Already I have taught you. Hoping up to this part everything is clear. Great. Now let's come to the another question. From last 5 years, they are not asking question from auto transformer. So there is very high chance. I'm hoping that this time they may frame one question from auto transformer also, because it is highlighted in your syllabus. So please go through the auto transformer at least once, all the conditions and all in your revision. Now please observe here. 100 kVA 4000 by 500 volt single phase 2 winding transformer is to be reconnected as auto transformer in two possible ways. Figure A, figure B. Shows in figure A and B the maximum kVA output rating of the transformer in figure A and B are dash and dash respectively. Hoping you are able to see the figures. So we have a 2 winding transformer 4000 to 500 volt. This transformer is of 100 kVA, and now we are going to connect the windings of the transformer just by shorting 2 different wires out of the 4 different terminals in order to make it as an auto transformer. Okay? Yes, sir. Yes, sir. So please observe, this is given. Now I'm just going to relate it by the 2 winding transformer first, so that you can easily understand this topic. Now please observe here. We have a 2 winding transformer. Yes, sir. And this transformer is of 100 kVA. When I am saying 100 kVA, it means it can maximum deliver a load of 100 kVA. And when you observe the voltage rating, it means the insulation corresponding to the high voltage side is such that it can withstand up to the maximum possible voltage of 4000 volts. Similarly, 500 volts means LV side insulation is such that it can withstand if delivering low voltage side up to 500 volts only. Is it okay? Yes, sir. So, it is very easy to calculate the rated secondary current and rated primary current. Rated secondary current and rated primary current. Rated secondary current and rated primary current. Yes, sir. So, what is the rated primary current? Sir, rated primary current is rated KVA by rated voltage on, this is a high voltage side, so you can say high voltage side. Yes, sir. So, what is the rated voltage on high voltage side? 4000 volts. Because KVA is nothing, voltage into current. So, voltage depends upon the insulation provided while designing, and current depends upon the thickness of wire provided while designing. Once the transformer is designed, you are not going to change the thickness of wire, and you are not going to change the insulation. You are just going to connect any two terminals in series, or you can say you are going to short these two terminals in such a way that it will become auto transformer. I am just giving the naming of the terminals as H2, H1 and L2, L1, and that we also know by finding the polarity test. Polarity test suggests that H2 and L2 are in same phase and H1 and L1 are in same phase. Is it okay? Yes, sir. So, what is the rated value? Rated value will become, sir, 100 kVA by 4000. So, this is 25 ampere only. Great, sir. And what about the secondary? It means the primary winding thickness is such that it can withstand up to 25 amperes. And what about secondary, sir? Secondary rated current is rated kVA divided by rated voltage. Yes, sir. So, rated voltage on secondary side is 500 volt. It means 100 into 10 to the power 3 by 500. Yes, sir. So, how much? This will be 200 ampere. Is it okay? Hoping up to this part everything is clear. Yes, sir. So we have this transformer. I am going to connect this transformer as an auto transformer. We have a wire. I am just going to purchase a wire, and with the help of wire I am going to connect the wire in such a fashion that it will become like this. Let us suppose this to be H2, H1. Let me first write here. This to be H2, H1. It can withstand up to 4000 volts, and this to be L2, L1. So I am going to short with the external wire. Which terminals I am going to short? Sir, I am going to short the terminals H2 and L1. So I am going to connect with this external H2 and L1. So when I am going to short, this will be a one terminal. Yes, sir. This will be a one terminal and this will be a one terminal. So total 3 terminals are available. Now you can easily observe, and that will be represented in this format. So internally I am not going to change the insulation and all. Just the out terminals I am going to connect in order to make it auto transformer. Now please observe here. If internally I am not changing, it means H2, H1 can withstand up to 4000 volts only, and L2, L1 can withstand up to 500 volts only. But if it is connected in this manner, then we know that if H2 and L2 are in same phase, it means for a positive half cycle or for a negative half cycle, these two can be added, and the entire voltage that can be withstand by this series connection will be equals to 4000 plus 500, 4500 volts. Yes, sir. And if we talk about current, so what is the current? We all know that transformer always operate on a magnetic subtractive polarity only. What is magnetic subtractive polarity? If the current enters through one dot, then current must leave other windings which is mutually coupled through dot only. So if the current is entering through one dot, it will create MMF in this way. This current must leave through the dot so that it will create MMF opposing to the main MMF. That is the only way we can use the transformer, any transformer. Yes, sir. So this indicates if the current enters through one dot, then at the same time current must leave through the other dot in the magnetically coupled winding. So you can assume here. Let us assume that current is entering here in any positive or negative half cycle. So you can say, sir, let us suppose the current is coming in L2. So if the current is entering through dot, then the current in the other winding must leave through the dot, and accordingly you can make the you can apply the KCL at this particular electrical connection, at this particular node. Yes, sir. Now please observe here, this L2 L1 winding thickness is such that it can withstand up to the maximum current of sir 200 ampere. This I2 rated is 200 ampere. So the thickness of L2 L1 is such that it can handle a maximum current of 200 ampere, and the thickness of winding H2 H1 is such that it can handle a maximum current of 25 ampere. Now you can easily identify the current by KCL 200 plus 25, 225 ampere. The voltage V multiplied by current is your KVA. So what is the KVA in this? Sir, 225 is the current, and what is the voltage across the terminal this available? That is 4000. So 4000 into 225. You can easily opt in the value. Similarly, if you observe here, sir, this will be 4000 and this will be 500. So how much voltage I can apply or I can get here? Sir, you can maximum apply a voltage here will be, this is a series subtractive polarity. Yes, sir. This will be your H2 H1 and this will be your L2 L1. So it's a series of subtractive polarity. Yes, sir. From the series subtractive polarity, you can observe 4000 minus 500, that is 3500 volts. So it means I can maximum apply or obtain across the terminal, this will be 3500, because the windings are connected in a series subtractive polarity. Okay. Yes, sir. Now let's talk about the current. Sir, current depends upon the thickness of wire. The thickness of H2 H1 wire is such that it can maximum handle a current of 25 ampere, and L2 L1 can handle a maximum current of 200 ampere. Yes, sir. So, sir, we can take any condition reference. Yes, either you can start from H2 H1 or from L2 L1. Let us take this as a current. You can take any reference. So let us take this as a current. Maximum current can flow is 200 ampere. This current is leaving through dot. Please observe, this current is leaving the winding L1 L2 through dot. So the current in the other winding must be entering through dot, and the maximum current that can flow depends upon the thickness of wire. Thickness of wire is such that it can maximum handle a current of 25 ampere. Now based on this, you can apply a KCL here. So KCL will be, sir, 200 minus 25, that is 175 ampere. So what is the KVA rating in the second case? KVA rating in this connection will become 4000 into 175. You can easily calculate the values. Sir, can we use the formula? Yes, you can use the formula in case of additive polarity, but subtractive polarity case, formula is not valid. So remember about that. This will be 4000 into 225. That is 900 kVA. 900 kVA. And 4000 into 175. That is 700 kVA. So now you know, in case if we are going to make an auto transformer, and we want auto transformer rating to be 4500 by 4000 volt. But in case if you have connected the windings without doing the polarity test, then see what happened. It can maximum handle a kVA of 700. However, you wanted to design a auto transformer which can handle a kVA of 900 kVA. Is it okay? So hoping you are able to understand this question also. Please let me know by writing in the comment section if you have any issue with anything. Is it okay? Great, sir. Oh. Sir, 3500 into 3500 into 200. You can use it either from HV side or LV side, it doesn't matter. You can use it from either the side, it doesn't matter. HV or LV will remain same. 3500 into 200 is also 700 kVA only. Okay. HV and LV side kVA rating will remain same. Okay, great. Come to the next question. Hoping this one question will going to help you to solve any of the question based on the auto transformer. Okay. Always remember that the first connection, which is additive polarity, it means both the two winding transformer voltages I'm going to add, and that will become a HV side, and the high voltage side of the two winding transformer become LV side of auto transformer. If you treat this to be VH or by VL of the auto transformer, you can use the formula of A auto. You will always get the highest kVA rating when we are going to connect the auto transformer from when we are going to connect the windings of the two winding transformer as the auto transformer. Great. Now please observe this question, NAT type. NAT type, please observe. Please observe NAT type. The rotor resistance and reactance of a 3-phase 50 Hz 4-pole induction motor are 0.15 ohm and 0.75 ohm per phase respectively. Assume that the voltage drop in stator is negligible and rotor resistance is constant. Voltage drop in stator is negligible and rotor resistance is constant. If the full load slip is 5%, then the ratio of maximum torque to full load torque is. You need to find the maximum torque to full load torque ratio. Can we do? Yes, of course. Of course. Now please observe, we need to find the maximum torque to full load torque. This is very important. Okay. Please observe here, in case if the stator impedances are neglected, and if you observe the torque slip characteristic curve, torque, you can write speed or slip. This axis is increasing speed and this axis is increasing slip. Okay. Yes, sir. Now, the torque slip of the 3-phase induction motor will be like this. Yes, sir. Induction motor, very important. Why, sir? Presently, induction motors will have a lot of use in the electric vehicle. Even some advancement of the this induction motor will be done with some reluctance motor in order to make better performance. Okay. So this is very important topic. You must need to understand the induction machines. They have a very wide future. Now please observe. So we have torque versus speed. This is the slip at which torque is maximum. In case if the stator impedances are neglected, the slip at which torque is maximum is R2 dash by X2 dash, where dash shows referred value to the stator side. However, it's a ratio, so you may write it as R2 by X2 also, because both will have a same reduction factor. If you are multiplying with a square on the numerator and denominator, it will give the same result. Yes, sir. So from here we have R2 dash. What is the value of the rotor resistance? 0.15 ohm. And what is the standstill? What is the standstill reactance of the 3-phase induction motor? Sir, standstill is given to you as 0.75. So now we know about this. Okay. Further, full load slip is given to you. 5%. So you can write it as 0.05. This is the data which is already given to you. What is full load, sir? It depends upon the type of load. Let us suppose this to be the load and this is your full load. Okay. Yes, sir. Yes, sir. This is the full load condition. Okay. Yes, sir. Torque produced under full load condition. So let us suppose this to be the full load torque. So let us suppose this to be the full load torque. This is a starting torque. This is your maximum torque. Yes, sir. And this is your full load torque. Okay. Okay. Now please observe here. When we talk about on neglecting stator impedances, on neglecting stator impedances, what is the torque expression? That is 3 by omega sm into v square by r2 dash by s square plus of x2 dash square into r2 dash by s, where s is nothing but it's a your full load torque. Okay, full load slip. In case of full load, you can just put the slip as full load. However, maximum torque expression in case if the stator impedances are neglected is 3 by 2 omega sm into v square, where v is the per phase voltage, upon x2 dash. Okay. Yes, sir. So when we are going to mark it as full load, this will become full load, this will become full load. When you are going to put the slip at the time of start, then the torque will become starting torque. So full load or starting, whatever you want, you can take the ratio. So just I am going to write it here, that full load to maximum torque. I think the same thing will be asked in the question. Yes, sir. In the question, I have asked about the ratio of maximum torque to full load torque. I have asked about the ratio of maximum torque to full load torque. So full load torque to maximum torque, if we calculate, this will become 2 upon. Please observe, R2 dash by X2 dash is ST max. So by solving ST max by SFL, it will become, and this will become SFL by ST max. Rest of all of the things are going to be cancel out in the ratio. Okay. Yes, sir. So it is very easy to calculate now about the full load to maximum. Similarly, you can find the ratio of any torque, operating torque, by maximum torque. Okay. Yes, sir. So 2 by ST max. What is the value of ST max, sir? It is given R2 dash by X2 dash. In the format of R2 dash by X2 dash, it is given. What is the value, sir? This will be 0.15 by 0.75. 0.2, we have this as 0.2 and 0.05. So I'm just going to put it as 0.02. 0.2 by 0.05 plus of 0.05 by 0.2. Done. Yes, sir. We can easily find the ratio. Once you have ratio, you can find maximum by full load. Most of the students do the mistake in the NAT. They put the same value. However, whenever you are solving the question, you need to go through this last line more than one time. What type of ratio they are asking? Hoping you are able to understand up to this part. If you have anything, if you want to ask anything, please feel free to ask. So it's a 2 point, in my calculation it will be 2.125. Whatever you are getting, this divided by 100, divided by the 1 divided by the same, whatever you are getting, just do 1 divided by that value. Up to this part, everything is clear? Great, sir. Great, sir. So they may ask you maximum to starting, they may ask you maximum to full load, or at any slip S. Now please observe here. Next question, very important. Please see. A 3-phase, 2-pole, 50 Hertz star connected cylindrical rotor generator has the following data. Flux per pole is given to you 4 Weber per pole. Flux is given to you. Number of slots 90 and number of turns per phase is 12. If the coil is short pitched by 30 degree, then the phase voltage on no load will be. So they are asking about the phase voltage in this question. How to calculate the phase voltage on a no load? Induced EMF will be same, only the current is not flowing. So what is the induced EMF? All of you are aware with the induced EMF in the AC machine. What is induced EMF in the AC machine? That is under root 2 pi f phi dph kc into kd. Yes sir, we all know about this. This is the phase voltage, RMS value. Yes sir. You may also put this under root 2 into pi as 4.44 f phi dph kc into kd. All of you are aware with this. Yes sir. Also you know that what is the value of kc? Kc is a coil pitch factor, and that is equals to cos alpha by 2 for fundamental, and in case for nth harmonic if we have to calculate, then that will become n alpha by 2, because the electrical degrees of nth harmonic is n times of electrical degrees of fundamental. Yes sir. What about kd? Kd is sir sine m beta by 2 upon m sine beta by 2. M sine beta by 2. However, if beta is very low, if beta value is less than 15 degree or near to 15 degree, you can just put it in terms of phase spread also. Sine phase spread by 2 upon phase spread by 2 in radian, where phase spread is the distance, the angular distance from one phase to another phase is started in the stator winding. Okay. Yes sir, and that will be same as m beta. Okay. Yes sir, great. Okay, so let's solve this. First I need to find m. What is m sir? M is called as number of slots per pole per phase. Per pole per phase. So how many number of slots? 90. How many number of poles? This machine is of 2 poles sir. So 2 and phase 3 sir. Great. Phase 3 sir, given that 3 phase 50 hertz star connected. Great. So we have 90 by 6. Great. This is m. Similarly, we can find beta. What is beta sir? Beta is 180 into pole. That will give you electrical equivalent of a 360 degree mechanical. Electrical equivalent of a 360 degree mechanical, 180 into P. And if you are going to divide it by number of slots, you will get slot angle. What is slot angle? Displacement of one slot with another slot, or you can say it is angular distance from center of one slot to the center of another slot. Okay. Yes sir. So this will be 180 into pole is 2 and number of slots is 90. So we have a beta. Yes sir. If we have a beta, we may calculate m beta. Okay sir, and that is what we called sigma. So we can calculate kd. Okay, whether it is a NAT type or NAT type or NAT type. So it means either you can go by the simple m beta by sine sigma by 2 upon sigma by 2 in radian, or you can calculate the actual value. The range will be given in the same fashion, that every answer, the answer in the range is going to be correct. Okay. Now please observe here, this will become m is equals to 90, number of slots are 90, number of poles are 2, number of phases are 3. So slots per pole per phase. Slots, number of slots per pole per phase. So this will be 15. Okay. Number of slots per pole per phase. Okay sir. And if we talk about beta, so this will become 180, that will be 4. So for 4 degree, you can say, sir, m beta can be represented in sigma 60 degree. This 60 degree is also called as narrow phase spread in case of narrow phase spread in case of 3-phase machine. Okay, it may be a 60, it may be a 120. 120 is preferable because for a wide phase spread, that is 120 degree phase spread of a 3-phase machine, already all the third harmonic components of the generated voltage are going to be eliminated. Okay, yes sir. Further, KD is sine sigma by 2 upon sigma by 2 in radian. So you can say, sir, this will become sine 30 upon, this will become, sir, 60 into 60 by 2 into pi by 180. Why I'm writing pi by 180? In order to convert these degrees into radian. Okay, so we have KD. And what about KC? KC is cos alpha by 2. Already short pitching is given to you in the question itself, that it is short pitched by 30 degree. So if it is short pitched by 30 degree, this will become 30 by 2. So we have a KD also. Okay, yes sir. Now please observe, per phase induced DMF is 4.44 into 50 into, I have just multiplied the under root 2 and pi. So F is 50, phi is 4 Weber per pole. It should be in Weber only. Yes sir, 4 Weber per pole. Then cos KC and KD is cos alpha by 2 and sine that one. So cos 15 is 0.9695 into sine 30 pi by 6. So I have just multiplied here this KD into 450 into 4.44. So I'm getting the phase voltage as 2. I have missed 4.44 into 9695 to sine 9549. Okay, so 9549 9695 calculation you need to check. Oh, again I have missed the 0.5. No issue. So calculation you can check. Please write in the comment section if you have done the calculation. Sine 30 by pi by 6. Point 9549 0.9695 into 4 into 44. Still the turns, number of turns are still missing here. So 822.114 into turn per phase. Now that is also very important. We know about the total number of turns. We know about the total number of turns. What is total number of turns? Number of turns per pole, per phase. Number of turns per phase is given to you 12. So you can just multiply it by 12. Number of turns per phase is given to you. Let us suppose if the total number of turns are given, say T. So in case of 3 phase, it will become T by 3. In case of 2 phase, it will become T by 2. In case of single phase, it will remain T only. So that is very important. You have to notice here. So it is given in the terms of number of turns per phase. So we know about the number of turns per phase, just multiplied by 12. So this will be 9.865 kV. Hoping you are able to understand this question properly. Okay, one more thing. If this machine is of 3 phase, they may ask you about the line voltage. You can calculate just by multiplying by √3. In case if the machine is of 2 phase, then turn per phase you have to be careful. Also you need to be careful in terms of number of slots per pole per phase, and that is M. Okay, so these two things are very important. Great. Very simple, formula based. Hoping you are able to understand that question. Great. Now a challenging question. MCQ, but it's a challenging question. Why I'm saying challenging question? It's a different from the regular traditional questions asked on the synchronous machine. So it's a little bit different. Try to solve this question. It's a challenging question. Now please see, a 3-phase cylindrical rotor synchronous generator is connected to a infinite bus. At rated voltage. The synchronous reactance of the generator is 1.5 per unit and the armature resistance is negligible. I am going to tell you very important thing in this question. Please see. If the excitation EMF is 2 per unit, the generator is operating at a power factor of 0.9 lag, then the load current and power angles are. So in this question I am asking about the load current and power angle. Okay, yes sir. Basically we have a synchronous generator. Armature resistance is neglected. Terminal voltage is 1 per unit and EF is also given to you. So EF is 2 per unit at an angle delta. If I am going to take V as a reference, that is 1 per unit at an angle 0. What about the current? Sir, this generator is delivering the current IA as IA at an angle of minus of cos inverse 0.8. Can I say this? Yes sir, great. So what is IA? IA is IA at an angle of minus of cos inverse 0.9. What is the power factor? 0.9. This is JXS. Great sir. Now if I am observing this, there are two unknowns. One is your load angle delta. It is not known to us. Another thing is we don't know about the armature current. Yes sir. And both are being asked in this. Great sir. The greatest advantage of phasor equation is that a single phasor equation is capable to solve two different unknowns. Okay sir. How sir? Please see. Please see. I can write a phasor equation as EF phasor is equals to V phasor plus of IA RA plus JXS phasor. Yes sir. However, RA is neglected, so you can write V phasor 1 at an angle 0 plus of IA. So I am writing IA as we don't have IA magnitude of the IA, so just writing IA at an angle of minus of cos inverse 0.9 because power factor, operating power factor is given to you into JXS. XS is given to you as 1.5 per unit. XS is given to you as 1.5 per unit. So I am writing here as 1.5. Is it okay? Great sir. What is EF? EF is also given to you 2 at an angle delta. Yes sir, great sir. EF is also given to you as 2 at an angle delta, 2 per unit and delta. Okay, yes sir. So you can write here as 2 cos delta plus of j 2 sin delta. Yes sir. Okay sir. What is j? The term j means at an angle 90. Okay. So this j 90 is going to be 90 minus, you can write cos inverse 0.9. Okay. Or you can just put the values here. So 1 plus of, this will become IA cos of phi. Okay. Cos of phi 2, where phi 2 is the load power factor. You can just write cos of phi. Minus of JIA sine of phi, where phi is cos inverse 0.9, where phi is nothing but it is cos inverse 0.9. Okay. Yes sir. So when I am going to multiply it by j 1.5, this will become j 1.5. Okay. And that will become 1.5. J and j will become j square. Yes sir. J and j will become j square, and j square is minus 1. Minus and minus will become plus. Yes sir. IA sine of phi. Can I write in this way? Yes sir. The greatest advantage of phasor equation is that real part of RHS and LHS are equal. Real part of RHS and LHS are equal. Imaginary part of RHS and LHS are equal. Imaginary part of RHS and LHS are equal. This helps us to make two different equations. Okay. Okay. Yes sir. By squaring, on squaring and adding equation 1 and 2. On squaring and adding equation 1 and 2. Okay, this is cos. Sorry. So cos part will become imaginary and sine part will become real because it is multiplied by j. So on squaring and adding equation 1 and 2, this will become 2 square because cos square delta plus sine square delta is nothing but value 1 only. Yes sir. If you observe this side, it will become 1 plus of 1.5 IA square plus of 2 into 1.5 IA square sine of phi. Yes sir. Great. Power factor is known to us. Cos phi is given to us, so we know about the sine phi only also. Yes sir. Since cos phi is equals to 0.9, what is the value of sine phi? We have the value of sine phi also. What is the value of sine phi? So sir, cos sine phi is 0.4358. Great sir. So this shows a quadratic equation. This shows a quadratic equation. Yes sir. This will be multiplied by 3. Okay. Yes sir. This is IA only. IA square. IA. Okay. Yes sir. So 1.3. Can easily write it here as 1.5 IA whole square plus of 1.3076 IA and minus of 3. Yes sir. Now you can easily calculate. So now you can easily calculate the value of armature current. Once you have armature current, you can calculate the value of delta either by using equation 1 or equation 2. Yes sir. Great. So let me solve the equation. Yes, up to this calculation, the question will be available in GATE. Okay. So the quadratic 3076 minus 3. So we have two values coming. One is positive and one is negative because it's a generator. So we can discard the negative value and choose the positive value only. So I'm discarding the negative value and choosing the positive value. That is 0.9 per unit. And once we have IA, we can put either in equation 1 or equation 2 to find the value of delta also. So from equation number 2, I can write here as 1.5 into 0.9 into cos phi is 0.9 by 2 sine inverse. So delta is 37.408 degree. Okay. Yes, sir. Great. Always remember, a single phasor equation is capable to solve two different unknowns. A single phasor equation is capable to solve two different unknowns. Great question. Sometimes I'm just going to make the simple part of this question also. Sometimes load angle is also mentioned to you. Only you need to find the armature current. So in case if the operating load angle is also given to you, then you can directly solve. How, sir? Let me show you one important relation, and that relation really is going to help you a lot. Sometimes armature current is given to you, like if it is operating at rated condition, then only you need to find the load angle delta. So this type of question sometime asked, and you can go by the simple rules. Please see. Just make a note point here. Okay, an important relation. Now please see, what is the phasor equation? EF phasor is equals to V phasor plus of IA RA plus JXS phasor. Sometimes we also write it here as V phasor plus of IA ZS. Very important. Please observe. I forget to take that question also in this sheet. So I'm just going to take the concept here. Very important. Please observe. Okay, sir, let V as a reference. So if I am taking V as a reference, then EF phasor will become, for a lagging power factor, let us assume a lagging power factor. It will not going to change the concept. Okay, in lagging or leading, just see. Let us suppose a lagging power factor concept. So this is your load power factor, lagging. This will be your IARA. IARA is in phase with IA. We all know that resistive drop is always in phase with the current, and reactive drop is 90 degree leading to the current. So JIAXS drop is 90 degree leading to the current. This will give you EF at an angle delta. I know we need not to represent this J term when I am representing a phasor diagram, but only I am mentioning in order to make you comfortable for writing the equation. Okay. Yes, sir. To relate the equation. Already this is only a magnitude of IAXS. Okay. Already phasor is represented, so only this magnitude need to represent. But I am writing this J term only in order to understand this flow of the equations only. Okay. Yes, sir. Now please observe. What is this one? Sir, this is your IAZS at an angle of theta s. Great. Now please observe. Very important. Please observe. Many times the questions are asked from this. Very high possibility they may frame the question from this part. Please observe. Now please observe. I have just increased this reference line ahead. So what is this? Sir, this is nothing but phi only. This is nothing but I'm sorry. This is nothing but theta minus phi only. Okay, great. What I can write this one, sir? We can write it as EF cos delta. And what is this V magnitude wise? So what is this line representing? What is this portion of the line is representing? Sir, it is representing V minus EF cos delta minus V. EF cos delta minus V. Yes, sir. Yes, sir. Very important. Very important. What is this line is representing? What is this line is representing? This line is representing EF sine delta. EF sine delta. Yes, sir. Yes, sir. Great. So one can say, sir, this is a base, and this is a perpendicular, and this is a right angle triangle. If I observe here, then I am able to see this triangle as a right angle triangle. I am able to see this triangle as a right angle triangle, sir. I am able to see this triangle as a right angle triangle, sir. Where this portion is EF cos delta minus V, and this portion is EF sin delta, sir. So I can write IA ZS square by Pythagoras theorem. Simply, IA ZS square is nothing but EF cos delta minus V square plus of EF sin delta square. When you are going to write this, will going to convert it into a simple equation. IA ZS is equals to root over of EF cos delta square and sin delta square will become EF square only plus of V square only minus of 2V EF cos delta. Very important relation. Very important relation. Please remember this very important relation. Okay. Yes, sir. It helps you to calculate armature current or sometimes load angle delta very fastly. Okay. Great, sir. So it's just a note part. You need to remember this part. It's going to help you a lot for finding the values of delta in case if the machine is operating at rated voltage, EF is given to you, V is given to you. So you can easily calculate the load angle delta in order to proceed further in the questions. However, for this particular question, in the last question, we have to go in the similar pattern that I have followed. Okay. Great, sir. Now come to the next question. It is based on the salient pole alternator. Please observe. This question is based on the salient pole alternator. A three-phase salient pole alternator has the values of direct axis and quadrature axis reactances as 1.3 per unit and 0.8 per unit respectively. Generator is connected to an infinite bus at rated voltage. If the generator delivers a rated current of 0.85 power factor lag, then the value of excitation power will be, we need to calculate the value of excitation power. We need to calculate the value of excitation power. Okay. Yes, sir. Yes, sir. Whenever a question asked from the salient pole machine, always you need to recall the steps. First step is you need to calculate Q axis locator. Yes, sir. And then from the Q axis locator, you get the value of delta. Once you have the value of delta, you can calculate the value of psi for the given power factor phi. Once you have psi, you can calculate ID. Once you have ID, for under-excited or over-excited, you can calculate actual excitation in case of a salient pole machine. Yes, sir. So I'm going with a step. Whenever a salient pole machine question will be asked, first step is Q axis locator, and that is EF dash phasor is equals to V phasor plus of J, or you can say plus of IA RA plus JXQ. Okay, quadrature axis you have to take in consideration for finding the value of this. Okay, yes, sir. So since RA is neglected, only XS is there, so XQ is there, so you can go with XQ. So EF dash phasor is equals to, everything is known in per unit, so best is to go 1 at an angle 0 plus of IA. Whether it is operating at rated or not, yes, sir, the generator is delivering rated kVA. When I am saying rated kVA, it means rated current upon base current. Base values are taken as rated values whenever per unit values are mentioned onto the nameplate. That indicates rated current upon base current. Base current is a rated current, so rated current is also 1 per unit only. in terms of per unit at an angle of minus of cos inverse 0.85 lag into xq. What is the value of xq? Sir, xq is given to you as 0.8. Okay. Yes, sir. So by solving this, you will get the value of load angle delta, because EF dash is nothing. EF dash is EF dash at an angle delta only. So I am interested to calculate the magnitude of EF as well as load angle delta. Great, sir. So one angle, you need to change it into polar. Okay. Minus of cos inverse 0.85 to 0.8i. 1 plus answer. This will be 1.575 angle 25.56 degrees. So it means we have EF dash and load angle delta as 25.56 degrees. This is not your answer. This is not your answer. This is just a EF dash only. Now whether it is operating on a lagging or leading, lagging, sir. Generator or motor, alternator, sir. It means lagging power factor alternator is a overexcited, sir. So we know that this machine is a overexcited machine. So for a overexcited machine, we have to calculate EF magnitude as EF dash magnitude plus of ID XD minus XQ. Yes, sir. This is always valid. It's a magnitude only. Where we need to calculate first ID. And how to calculate ID? ID is equals to IA sin psi and IA sin psi, where IA, what is sin psi? Overexcited or underexcited, sir? Overexcited. So what is psi? Phi plus delta magnitude. Magnitude of phi plus magnitude of delta. IA is given to you as 1 per unit. Sin phi is cos inverse 0.85. Yes, sir. Cos inverse 0.85. So we have 31.788 plus load angle delta we have calculated here. That is 25.56. So you can just put it here. 25.56. If you want to ask anything, please feel free to ask. You can write in the comment section. Okay. So 0.8419 per unit is your direct axis current. Great, sir. Once we have a direct axis current, then EF magnitude is EF dash magnitude, which we have calculated as 1.575. So 1.575 and plus of magnitude of the ID is 8419. Most of the students do the mistake while writing this equation. They put I or an imaginary term here. So always remember, it's a magnitude. It's a magnitude now. It's not a phasor equation, just a magnitude equation. Okay, sir. XD minus XQ. XD minus XQ. 1.3 minus 0.8. 1.3 minus 0.8. Hoping you remember about the slip test to find the values of XD and XQ. Yes, sir. So 1.5 minus 0.8. Then just add 1.575. So 2.16 per unit. Hoping you are able to understand this question properly. Yes, sir. Great. So in this way, you can easily solve this type of questions. Whether they have asked about the excitation voltage or excitation power. Sorry. See, they have asked about the excitation power. They have asked about the excitation power. They haven't asked about the excitation voltage. So this is not your answer. This is not your answer. Now, further you need to write power angle equation is VEF by XD sine delta. This is a per phase power plus of V square by 2 1 by XQ minus 1 by XD sine 2 delta. Yes, sir. But this is a reluctance power. They are asking about the excitation power only. So this portion is power of this portion of the power is called as a excitation power. So for excitation power you can write voltage V EF by XD sine delta. Whether they have asked about the maximum or just the excitation power. Sir, just the excitation power. So what is the load angle? 25.56. We know about the load angle. This is a per phase. For 3 phase you can just multiply it by 3. Yes, sir. For 3 phase you can just multiply it by 3. So 3 into V is known to us because it's a 3 phase. Okay. So V is known to us 1. EF we have calculated 2.16. XD is given to you 1.3. Sine delta is given to you. You have calculated 25.56. Now you know about the excitation power. What is excitation power? What is excitation power? 2.16 into 2.15. Oh, I am very sorry. I am substituting the values on per unit and then I have multiplied by 3. I am very sorry. For per unit, you need not to write it here. 3. Okay. So please check it here. I have done a mistake because the values I have given in per unit, you need to put it in 1 into 2.16 divided by 1.3 sine of 25.56. .716 per unit. Kindly check the calculation. Hoping up to this part everything is clear. Yes. Diksha Jaishwal, absolutely right, beta. Great. So hoping up to this part everything is clear. There is no confusion. Great. Now please observe one more question. It's based on the DC machine. Okay. Please see. The armature and field winding resistances of a 120 volt DC shunt machine is 0.5 ohm and 60 ohm respectively. Machine is connected to a rated supply and it's operate as a generator for some time and then as a motor. In both the modes, line current of the machine is equal to 50 ampere. The ratio of speed as a generator to speed as a motor is ratio of speed as a generator to speed as a motor is. In both the cases, line current will remain 50 ampere. Both the cases, line current will remain 50 ampere. When we talk about DC machine, then DC machine will always be represented RA, EA and brushes. So whether the drop is given? No, sir. Voltage V is given to you, that is 120 volt. So when working as a generator, always remember applied torque and electromagnetic torque in the opposite direction. The armature power is entering into the machine, that is EA into IA, is developed power. IA, sorry for the right, IA, IL and IF. Yes, sir. This is also given to you 60 ohm. So you know about IF. IF is nothing but V by RF only. RF is 60 ohm is given to you. 120 volt V is also given. Yes, sir. Great. Further, the same machine is going to act as a motor. Same machine is going to act as a motor. So when the machine is going to act as a motor, again I am just representing the diagram. However, this diagram is in your mind itself now. V, yes sir. This will be your IL. Motor always takes the current to develop the armature power, and that armature power develops an electromagnetic torque into omega m, and load torque is in the opposite direction. RF is given to you. Armature power is coming from machine to mechanical side. RF is given to you 60 ohm, and IF you can calculate. Yes sir, great. So now only KVL and KCL is required to solve this question. Let this to be EA2 and condition 2, and this to be condition 1. IA as a motor and IA as a generator I am writing here. Yes sir, great. So load current of motor and load current supplied by the generator. Is it okay? Yes sir. 120 volt is the terminal voltage, sir. Great, sir. We can also observe the field current, that will become 120 by 60. It means 2 ampere is the field current, sir. You can easily observe here 2 ampere is the field current, sir. Great, sir. Now please observe. Sir, we all know that induced EMF depends upon the speed of rotation. It does not depends upon the motoring or generating action. Yes. And sir, EA for generator is V plus of IA RA plus any external resistance if connected in series with the resistance of armature. And in case if the brush drop is given, we need to take the brush drop also. Further, EG of EA of generator. So for generator, you can write N is speed as V plus of IA RA plus of VBD upon K phi. Similarly, for motor, what is a induced EMF in case of motor? Sir, it also depends upon the speed and direction of rotation only. And for KVL, by loop equation, you can write here. Okay, so this will become V minus IA RA minus VBD by K phi, where VBD is nothing but a brush drop. So you can write it here as speed of generator and speed of motor. So from here you can easily find the ratio of generator to motor. So generator to motor speed will become, sir, this will be V plus of IA RA plus of V in case of generator, and V minus of IA of motor into RA minus VD case of motoring action. What about the field, sir? Phi, let it be phi g and let it be phi m. So you can write it here as phi m by phi g, inverse proportional of this flux. However, if the field current is not changing, it means flux is not changing. So we have this ratio Ng by Nm. From now onward, we can write directly, sir. So this will become 120 plus of, what is the load current in both the cases? Load current in both the cases is given to you 50 ampere. So 50 minus 2 is 48 in case of motor. And if this is 50, then 50 plus 2, 52 in case of generator. Yes, sir. So you can easily write here, sir, 52 into RA is also given to you 0.5 ohm, 0.5 by 120 minus 48 into RA. What about VBD? It is not given, you can neglect. What about flux? Sir, field current is not changing, armature reaction considerations are not given, so it means flux will remain constant. So this shows the ratio. Hoping you can easily calculate the ratio, 1.5 27. Great, thank you. Hoping you are able to understand this question properly. Great, Diksha. Yes, sir. Great, great. Let's come to the next question. See, one more question. Only you can stuck in the language, otherwise this question is very easy. Only you can stuck in the language. Sir, it is given for both. Yes. Sir, load current is given for both 50 ampere. Yes. Please observe here. In the question itself, it is given that in both the modes, it means generating or motoring mode, machine is line current of the machine is 50 ampere. Line current of the machine is 50 ampere. So I have taken both as 50. So for generator it will become 52 and motor it will become 48. Now please observe this question. NAT type. You may stuck in the language. Otherwise this question is very easy. Please try to solve. You may stuck only in the language. Rest all this question is very small and very easy. Let me read first. A 4-pole wave-wound DC generator is delivering a full load current of 40 ampere to a load. It has 100 number of armature conductors and rotates at 1000 RPM. The net voltage drop across the armature resistance and brushes at full load is 0.67 volts. The power supplied to the load is dash kilowatt. Sir, very easy. Yes, very easy. If we talk about this generator, so this generator, what type of generator it is? A wave wound DC generator. We don't know about the field. We need not to know about the field because flux per pole in the machine is given to you. So this may be a permanent type, this may be a separately excited. We already know about the flux per pole. So we need not to care for the flux. Okay, sir. And we also know that this machine is rotating at a speed of 1000 RPM. So if we know about the flux and rotation, it means we can calculate induced EMF. Then RA and brush drop. The total net voltage drop is given to you, so you can calculate terminal voltage. If you have terminal voltage, then and you have EA, it is given that delivering a full load current of 40 ampere. This is given to you, 40 ampere. It may be taken as a IL or IA. Okay, yes sir. So we have the output power V into IL. What is V? V is equals to A plus of IA RA plus of VVD. Yes sir. Into IL. And what is EA? E phi Zn by 60A plus this drop is given as 6.67 and this current is given as 40. Means only we need to identify now P phi Zn upon 60A. So how many number of poles? This is a 4-pole machine. Flux per pole is 0.05. Total number of conductors are given as 100 number of armature conductors. Yes sir. So P phi Z. What is N? 1000 sir. Divided by 60. How many number of parallel path? Sir, only wave wound is given. Whether it is a simplex wave, duplex wave, triplex wave, it is not given here. So we have to take it as simplex wave only, and accordingly we have to put the number of parallel paths 2 only, plus of 6.67 into 40. Please tell me what is the calculation. 6.4. 6.4. 1 point. In the last one we are getting 1.1. We are 1.14. Okay. 6.4. Yes. We are getting 6.4. So this will be equals to 6.4 kilowatt. Now most of the students do the mistake here while reading this in case of NAT. Now you are not going to do any conceptual mistake. Only you are going to do the basic mistakes. What are the basic mistakes, especially for the machine, power system and power electronics? Especially for the machine and power system, if I'm going more precisely. And that is this units. You forget about the units. You do the mistake here. Sir, E minus IARA. Yes, beta. Sorry for this. E minus IARA. Yes, you are absolutely right. This is a drop, E minus IARA. It's a generator. E minus IARA. I'm extremely sorry. I do the mistake in the flow, but kindly correct it. Okay, rest all is okay. Yes. The drop is IARA plus VBD. Yes, please correct it. This is your IARA plus VBD. This entire drop is given to you as 6.67. Great. Hoping you are able to understand up to this part. You are comfortable in this? Great, sir. Let's do one more question. There is again a possibility that they may ask you question based on the simple impedance or primary current. So it's very easy. Just going to do this question. You all are aware with the equivalent model. Yes, sir. You can transfer this to this side. Yes, sir. So by transferring, you may get primary current IP as V, that is 100 volt at an angle 0 divided by V, that is 100 volt at an angle 0 divided by please observe root over of R equivalent. So this is 16 when you are going to refer it on the 100 volt side, then this will become 16 into 100 by 200 square. So that is 4 ohm only. Yes, sir. Plus of this minus J8 when comes to this side, it will be divided by 4 because divided by 2 square, that is 4. So minus J2, 5 minus J2 is 3 square minus of tan inverse 3 by 4. Very easy. You can easily do this type of question. If you have any issue with anything, please let me know. I have just kept it in order to make you comfortable. Yes, 20 at an angle of minus 36.86, that is 0.8 lagging. So 20.8 lagging. Is it okay? Sir, if the load is RC type, then why you are writing lagging? Load is of RC type, but due to the transformer leakage impedance, the entire impedance will become RL type and the input current is lagging. Is it okay? Great. Come to the next question. This is a good one. High possibility, because from the last 3 years I am not seeing any question based on the transformer losses. It's an important topic. They can't miss this topic. They are going to frame this year. Okay, it's an important topic. Please see, a open circuit test gives an iron loss of 1500 watt. Generally, we intentionally do the open circuit and short circuit test. In open circuit test, we intentionally do the testing by changing input frequency and voltage. Okay. Yes, sir. So please observe, it gives a loss of 1500 watt in 400 volt 50 hertz transformer at normal voltage and frequency. It means at rated voltage and rated frequency, 440 volt 50 hertz, the total loss is equals to 1500 watt. When 220 volt 25 hertz is applied to the iron loss is equals to 687.5 watts. Now you need not to care whether it is a LV side or a HV side, sir, whether V by F is constant or not, because the HV and LV is not defined in the question. It means both the time same side they are giving the supply. Is it okay? Yes, sir. Now the value of eddy current and hysteresis loss at normal voltage and frequency are. We need to calculate the eddy current and hysteresis loss. So let me write here directly Ke dash. What is Ke dash? Pt by F1 minus Pt2, Pt1 by F1 by minus Pt2 by F2 upon F1 minus F2. This will give you the value of Ke dash, and you can find Pe as Ke dash into 50 square, because 50 is the normal voltage, normal frequency. So normal frequency they are asking. And hysteresis loss you can easily write it out as total loss 1, because total loss is at normal frequency. So total loss minus Pe will give you Pt. Ph. You can easily do the calculation. Now, sir, how this portion will come? How you are getting the answer in the 3 different line only? Now, please observe. Actually, the total loss is eddy current loss plus hysteresis loss. The total loss is eddy current loss plus hysteresis loss. Eddy current loss is Ke into F square into Bm square, and Kh is Kh into F into Bm to the power x is your hysteresis loss. These are the experimental value. Okay. So from here you can say, sir, once the transformer is designed, then for V by F ratio constant, for constant V by F ratio, it means applied voltage to its frequency. If the ratio is constant, if for constant V by F ratio, for constant V by F ratio, V by F is proportional to Im. Basically, Im is proportional to V by F, that is proportional to phi, that is proportional to Bm. So in case if V by F ratio is constant, you can say Bm is constant. You can say Bm is constant. So if I am saying V by F ratio is constant, that indicates V by F ratio indicates constant V by F ratio indicates constant Bm. Okay. Yes, sir. So in case if Bm is constant, you can write it eddy current loss. You can write eddy current loss to be equals to Ke dash into F square, where I am writing Ke into Bm square as Ke dash, and hysteresis loss as Kh dash into F, where Kh dash will become this Kh into Bm to the power x. So total loss will become eddy current loss plus hysteresis loss. So in case if V by F ratio is constant, total loss can be represented as Ke dash into F square plus of Kh dash into F. Now at frequency F1 and F2, you can write, sir, Pt1 by F1 is equals to Ke dash F plus Kh dash, and Pt2 by F2 is equals to Ke dash F2 plus of Kh dash. By subtracting higher loss to lower loss, yeah, or you can directly observe Pt1 by F1 minus Pt2 by F2 is equals to Ke dash into F1 minus F2. So basically, I am just remembering this equation in case if V by F ratio is constant, in order to calculate the value of Ke dash. Once I have Ke dash, then I can just multiply. Once I have Ke dash, then I can just multiply by F square in order to find the value of eddy current loss at any frequency when V by F ratio is keeping constant. Yes, sir. So it is very easy to solve 1500 by 50 minus 687.5 by 25. How I get the V by F ratio constant? Previously it is 440 by 50 and now it is 220 by 25. So both are reduced by half. So V by F ratio is constant. Is it okay? Yes, sir. So if you solve, this will be equals to 0.1. This will be equals to 0.1 into 50 square. So 250 watts, and the entire is 1500 at 50 hertz. So minus 250, 1250 watts. That's all. Hoping you are able to understand this type of question now. Great. Chandra Prakash, great, great. Let's move to the next question. Now keep this in. Always remember this is only true when V by F ratio is constant. Okay? Yes, sir. Now please observe here. One more question. One more question. A 3000 by 2000 by 1000 volt single phase, single phase 3 winding transformer. Now I am talking about the multiple winding transformer. Reconnected as an auto transformer, primary side voltage of an auto transformer is 5000 volt, supplying a load of 1500 kVA at 600 volts and 3000 kVA at 2000 volts to the secondary side. Assuming the loads having same power factor, the value of total current taken by the primary side is. You need to find the total current taken by the primary side. Okay. You want to try? Okay, sir. First of all, we have a 3 winding transformer, 3000 to 2000 to 1000. Before going to connect it as an auto transformer, I am observing what is the voltage rating of the primary side. So voltage rating of the primary side is 5000. That is only possible when 3000 and 2000s are connected in series. So I know about this is as 3000 and 2000s are connected in series. Okay. Yes, sir. Let me represent here 3000 and 2000s are connected in series. Okay, sir. Further, so this will become 5000. Yes, sir. This will be 5000. Yes, sir. Further, 5000 primary side voltage of the auto transformer is 5000 volts and supplying a load of 1500 kVA at 6000 volt. That is only possible if 1000 winding is also connected in additive polarity. Then only it will become 6000 side. So onto the 6000 volt side, load is connected, and that load is of 15 kVA, 1500 kVA. Yes, sir. Further, 3000 kVA load at 2000 volt through secondary side. So let this to be the 2000 volt side. 2000, 3000 and 1000. So one load is also connected across this side. Okay. Yes, sir. And this load is of 2000 volt. 2000 volt side. Load is of 3000 kVA. 3000 kVA. Great, sir. We are interested to find the current entering here. Okay. Also, it is given that assuming the loads having same power factor. So when the loads having same power factor, it means arithmetical sum of the loads or phasor sum of the loads will remain same. Yes, sir. So what is the total load? What is the total load onto the auto transformer? The total load onto the auto transformer is 1500 plus 3000. So this will become 4500 kVA, and kVA on input side and output side are same. Why, sir? Because it is not given that this transformer will have any drop, any resistance, any reactance, any power loss. It means whatever active or reactive power is delivering to the load, same active or reactive power is supplying from the source. Is it okay? Yes, sir. It's an ideal transformer now. So for that you can say, sir, input voltage into input current. Input voltage into input current is input kVA. Input voltage into input current is input kVA. So V1 into input current. Okay. Yes, sir. Is equals to 4500 kVA. Yes, sir. What is your input current? Input current, sir, this will become 4500 into 10 power 3 divided by V1, 5000 volts, sir. Okay. How much? 900 amperes, sir. Done. So it means this auto transformer is going to take this current I1 as 900 ampere. If you have anything, if you want to ask anything, please feel free to ask. Great. So hoping you have enjoyed this. Okay, please comment in the section that you want such more number of revision series, so that I can select more number of questions. Okay, it's a technique called as a random revision technique. When we have to use a random revision technique, when we do the revision and all, then only we need to recall the things. And how to recall the things? You can just choose a random question and try to solve. Okay, so I'm going to give this type of more question and going to discuss more questions related to the upcoming GATE exam, so that it will help you a lot in order to recall all the concept. Okay, GATE, great, sir. Short circuit and open circuit test of synchronous machine. Okay, Diksha, definitely in the next session I will take questions based on the OCSC test. However, already in the last 30 questions discussed on the GATE Wallah EC channel in Hindi, I have discussed that. But if you have language issue, I am going to discuss some more questions on this English Wallah channel also, so that it will give you a great help. Hoping you have enjoyed this session a lot. If you want to ask anything, please feel free to ask related to a upcoming GATE exam. If you are feeling any difficulty with any topic, you can suggest me in the comment section of this video. Definitely, I will try to take that particular topic through the question in this series. Thank you everyone. Lots of love. Thank you everyone. Thank you. Good night.